Visible irukkalama?
Created our
PPT
4.
I hope it is visible.
That is our
Clear irukkiya? Yaravadru
pass on to this module 5 and 6 now. So
presentation
module 5 and
irukkalama?
6 is
Broad idea.
with respect to the refrigeration and air conditioning. So module 5 is dealing with refrigeration and module 6 is dealing with the air conditioning system. So, almost these two modules are combined.
Start pannalama?
Combined,
Visible irukkiya
cover it.
presentation?
Both are interrelated. So let us first understand the difference between refrigeration and air conditioning. Both it seems to be same. There is a small difference between this refrigeration and air conditioning.
Visible irukama? Yaravadru solunga. Okay, na start pannalaam.
So if you talk about refrigeration,
Visible தான் சார் visible
it is always refers the cooling effect. It is low temperature. Refrigeration means we'll try to achieve a temperature slightly lower than the atmosphere.
In our previous
So
class,
that only we call it as a
we were seeing our
refrigeration.
refrigeration system.
Air conditioning.
So
Air conditioning
we are
is
seeing that
referred
there
to
are two
the
types of refrigeration system.
not only
One is
cooling,
vapor compression
sometimes it
and
also
absorption.
refers to the heating also.
In our last class,
Air
we were
conditioning
seeing
refers
the
conditioning
vapor
of
absorption
air.
system of ammonia and water.
Conditioning of air means
We are discussing.
it's not
There is
just
another
only cooling.
called lithium
Sometimes
bromide
it may
and
be
water
heating
absorption
also.
system. So
In
the
addition
previous
to
case,
that,
we have two. This is ammonia
we
and
have
water.
to maintain the other parameters, namely
In this, ammonia is the refrigerant.
humidity
Water will be the absorbent.
for our comfort, for the human comfort. So now let us understand how far that human comfort
In this,
depends on this
we
humidity
have
and all. For
water
example,
will
the
be the
refrigeration,
absorbent.
now if you
Second
see
one,
our
this
refrigerator,
water will
domestic
be the
refrigerator,
refrigerant.
or, our split AC,
Lithium bromide will
whatever
be
it
the
takes,
absorbent.
so we call it as a refrigeration.
So why do we use
But
specifically
in air
such
conditioning,
so-called lithium bromide? So
in
lithium
addition
bromide
to
is
that,
nothing but a salt.
your
It is
cooling
in the
effect,
salt form. It will be in the powder
sometimes
form.
a comfort
It is
condition,
having a very good
maybe
absorbing
a
hygroscopic
heating
material.
also. How,
Hygroscopic,
for example,
we
in
call
our
it as
country,
it will
it
readily
is,
absorb
you see
water
that
quickly.
it is, always most of the time
It can
year,
it can able to absorb
especially in our
with its
places and
volume.
all,
It can
it
able
is
to
very
absorb
hot,
maximum
so
amount
that
of
we always
water.
prefer
Like you take a
low temperature
like
in
you
the
take a wood and
in our
sponge.
particular space.
If you take
whether
your
it is the
wooden
office or
sponge,
room,
which will
whatever
absorb more
you
water,
call. But if
obviously
you see
sponge will
about in other
absorb more
places,
water. So like that we
in
can
other countries,
we can
Western
understand
countries
this.
and all,
Okay, like other
see
materials
that
compared to the other
outside
materials,
maybe
this
sometimes
lithium
cold.
bromide
Maybe it may go up to 5 degrees Celsius,
is
2 degrees,
hygroscopic
3 degrees
material.
Celsius.
Hygroscopic,
Even in
the
our
name implies
country
it
also,
can
some
able to
places.
absorb.
So
It
during
can
the
readily
time,
absorb the water.
we won't
Okay,
prefer
that's why we use this lithium bromide, and also the another
to have
advantage
the
is
low
why we have chosen
temperature
this for
in
lithium
our
bromide.
room or office, whatever it
Compared to
may be.
that
So we
water,
need a
its
warm
boiling
air.
point is very high.
Right. So in
Water
that
is
case,
100 degrees Celsius.
we
So
need
the lithium bromide
heat
is
the
it's more
air
than
and we have
1000.
to attain a
Okay,
required
so
comfort
1000,
condition,
100,
maybe the
1200
temperature
plus
of
it will come.
some
Because while
around
we're heating
20
it
degrees Celsius
in the
or 80
generator,
degrees Celsius. In outside
so
temperature
the
is very
lithium
much
bromide
lower.
should not evaporate. Only water should
So,
evaporate. In the previous
that
case, we have seen in this last class,
task
ammonia
cannot
water
be achieved
absorption
by
system.
a refrigeration
Only
equipment.
ammonia has to evaporate,
That
water
task
should
can be
not
achieved by
evaporate
a
because
air
ammonia is the
conditioning
refrigerant here.
Okay,
So
air
ammonia is a
conditioning
low
equipment.
boiling fluid. It
Refrigerating
can able to
equipment
evaporate at minus
whatever
30
we
degrees
use
Celsius. Water is
nowadays in our
100.
home and all, only refrigerating
So in
equipment.
this way, when we use these two
It can
materials,
give
one
only
should have
cooling
a
effect.
relatively very much lower
In
boiling
addition
point.
to that,
Here, we are
heating.
using water and lithium
We
bromide.
also
Water is
we need
100
to
degrees
understand
Celsius. It is
another
very high.
terminology
Lithium
called
bromide is more than 1000. Okay. So in this way,
humidity.
so we have this
What is
lithium bromide and
humidity?
water absorption system here.
Humidity is nothing but amount of
With
moisture
respect to the
content present
components
in the
here,
air.
with respect to that vapor
Sometimes you
absorption
might have
system,
seen
so it consists of
in our
four prime components:
suppose if you are watching
condenser,
our cricket or suppose
evaporator,
some other sports
absorber,
and all.
and generator.
So when they are giving the
So the components are
temperature
similar. Only thing is the
particular
refrigerant
place,
is changing.
they might have
with respect to the
specified
vapor
relative
absorption
humidity
system.
RH.
So if you recall your
They
vapor
specified as
compression system,
50%, 60%, 70%, like
instead
that.
of compressor, we
So what
have
is the meaning of
generator and
the relative
absorber here.
humidity?
Condenser and
Represents
evaporator
more
is
the
common
relative
for both
humidity,
the refrigeration
more
system.
the value of the relative humidity.
Condenser and
For
evaporator is
example,
common
if
for
the relative
both the
humidity is
refrigeration
80 or
system.
90 means,
So in that vapor compression
more
system, we'll have
moisture content
compressor
is present
and
in the
expansion
air.
valve will be
Air
there.
is,
So here, in place of that
air
one,
is
we'll have
fed up
generator
with
and
more moisture,
absorber.
and the relative
That
humidity
is
is
a completely a
100%
closed
means
system.
completely
It
air
is a
is
cyclic
saturated
process. So we can
with the
start
water.
anywhere here.
Water,
So
that
in
is
the
water
usual
vapor
way,
in the
we'll start it from the
supersaturated state.
evaporator. The
The relative
evaporator
humidity
outlet
is low means the air
will
is
be having a
no moisture. Means moisture is very less.
the water,
10%,
which will be
20%.
because water is the refrigerant here. So
Thank you.
only the
Exactly,
refrigerant has to
which
flow through the
relative
condenser
humidity
and the
will be giving us
evaporator. The other one will stop in the generator itself.
comfort. Whether
So
it is
we'll
a low
have a
humidity
water
or
at
a
the
high
output
humidity.
of your evaporator after
Any
giving
answer
away
from
its
you?
cooling effect. Okay, so
So
that
the
I'm
humidity
starting it
வந்து
here so that I will end
the
it
relative
here.
humidity
Being a
So
cyclic
எது வந்து
process.
நமக்கு comfort
So the water will be coming
whether it
out
is low
that
humidity
is in the
or high
vapor form
humidity.
because it has absorbed its
Low
heat.
humidity
So the water will be coming out from the
Low
evaporator
humidity.
and it enters into
இல்ல
the
மூணு எடுத்துக்கலாம் நம்ம.
absorber.
Low,
So here
moderate, high.
in the
இதுல வந்து
absorber already
எது
in the
வந்து
previous
comfort?
cycle, so you'll have
Any
the lithium
low
bromide
humidity.
solution will be there. So when the water is being sprayed here, so
கார்ல
it will readily absorb it.
மாய்ஸ்டர் அதிகமா
So
இருக்கு
you are
நமக்கு
just supplying a cooling water so that the vapor
ஏர்ல மாய்ஸ்சரைஸ் அதிகமா இருந்துச்சுன்னா நமக்கு
when it mixing with that
அன்கம்ஃபர்டபுளா தானே இருக்கும்.
your lithium bromide will be
moisture
cooled
content
positive.
is very high means it is
That's why
uncomfortable.
called as absorber.
But
So lithium
moisture
bromide will
content
be
is very
absorbing
low
the
means that is
water
also
here.
uncomfortable. எப்படின்னா
So now we'll
we
have the
always
lithium
prefer
bromide
moderate humidity.
solution here.
Even an air
So
conditioner
that lithium
will,
bromide solution is
will
passed to the
it will
generator
maintain a
through a
moderate
heat
humidity of
exchanger.
40
When
to
it passes through the heat
55,
exchanger,
60% only.
so the incoming
Let us understand the reason
lithium
of
bromide solution.
For
So it will be
example,
hot here.
let us
So
take
that
a high
will
humidity
heat
place.
the
For example, we
lithium
take two
bromide
places
solution which is going
state.
to the
We will take,
generator.
let's say, our Chennai. Take it to another place like our Coimbatore and all. Okay. So you see that temperature here in Chennai, for example, it is 40 degrees Celsius. Otherwise, not 40. Okay,
We call it
let us
as
take
a
some 35 degrees Celsius.
weak solution.
Okay.
This
The same 35
because
degrees Celsius
here the
temperature
water
will assume it in
content
Coimbatore
may be
also for
more
a particular
here.
day.
So lithium bromide will be less.
Okay.
That's why we call it as a
So,
weak solution.
temperature is same.
Strong solution means
Okay.
lithium
So
bromide content will
where
be
you
more.
will be feeling comfort
So
in
here we'll have
Chennai or
a strong
Coimbatore.
solution. Here we'll have a weak solution.
Obviously, our answer will be in Coimbatore.
So in this way, the strong
Yes.
solution of this
என்ன
lithium
reason?
bromide water absorption,
Because
the water
temperature
system
same
will be
இருக்கு,
passing
but
through
அங்க
this
தான்
heat
comfort
exchanger
இருக்கு.
where
என்ன
it is
reason?
preheated here. The
Cooling
ultimate
area
aim is we have to heat that and we have to
Cooling.
evaporate the water here.
இல்ல
So
நம்ம வந்து
we
so
do
we are
the
talking about
preheating
only
process
temperature
so
மட்டும்
that the heat
இல்லையா?
which is
So
to be
temperature
given
வந்து
here
ரெண்டு
will be
இடத்துல
less.
சேமா கூட இருக்கும்,
So
but
that
என்ன
the
சென்னையில
thermal
வந்து we
efficiency
feel
of the system will be
uncomfortable. என்ன
improved.
reason?
That's why we use
In the north,
we preheat the
yes, because it is a
your,
coastal area.
lithium bromide
Chennai is
water
coastal
solution.
area.
So when it goes
you
to
see
the
that,
generator,
during summer,
so we give some external heat
temperature
supply,
increases,
so that we call it
so
as a
more
QG.
water
The
will
generator
evaporate from
heat
the sea.
given to the generator
So when
here.
the water is evaporating, it is
We
the superheated
will
state,
be
it
giving
will
the
be
heat supply
air.
here.
So
So we know that
air
for
will be
vapor
added with the
absorption
more
system,
moisture.
so the amount of
When there is a more
energy
moisture,
given will
suppose
be
for example,
relatively less
relative
compared to the
humidity
vapor
is
compression system.
90 or
That is the
95%.
biggest advantage.
அப்படின்னா,
Even
so
a steam
see,
or
we all know
exhaust
that
gas,
sweating
so
is
that is
taking place
sufficient to
in our body to maintain our
for the
body
running of the
temperature.
entire system here. So
So
when
when
we
the
slowly
temperature is
give the
increasing,
small amount of
now
heat is given,
sweating,
slowly the water will be
what
heated.
is happening?
So when it is heated, when it
the water
reaches its
particles
boiling
from
point,
our body will
100 degrees
evaporate,
centigrade
and then
atmospheric
it will go
pressure,
to the air.
so it will
Already
be
all
evaporated.
air is saturated with the water molecules.
Only
So the
maximum
water,
majority of
coming out
the
from our body
water will be
not
evaporated here because the
So we'll be feeling
lithium bromide will not be
uncomfortable.
evaporated here.
Right. So
Because its
when
boiling
the
point is high,
humidity is very
so
high,
almost
the
98,
water
99%
evaporation
of
from our
water
body
will be
during sweating,
evaporated.
so
So
will
that
be
will
very
be
less.
passing through the
So that we'll be
condenser
feeling
here.
uncomfortable.
So
That
we
is one
use some
point.
external
So
cooling
that high
arrangement.
humidity is
We
uncomfortable,
condense
as you
the
said. Okay. Coming to that low humidity, very
your
low means the air will be
vapor,
so dry.
water vapor.
The
We
air will be
condense
so
this water
dry
vapor
means,
here.
so it
that
is a
we'll
10%
just
or
cool it here.
15%,
So that
20%.
the
Means in that
cold
case also will not be feeling uncomfortable
water
because the
which will
dry
be
air
coming
is
through
coming
this
and
passage. So it is the cold one
if
now.
you are
So what will be when
dry air
it
is
is
surrounded
just
by
supplying
us.
to this?
Again,
So we'll have
will
the
be feeling
evaporator.
uncomfortable.
So
Like
it is
our
a
desert
cooling
area.
place.
Desert is complete relative
So
humidity is
whatever
zero.
the load we keep it here.
Desert, there
the
is no
cold
water. So if you see
refrigerant.
that
It's nothing but a
even
water
it is slight
here.
rise
So when
in
it comes
temperature.
here, so maybe
So
it will be around
the dry air will be
lower temperature. So
its
it may not
surrounding
go
will be
below
the-
0 degrees Celsius.
The dry air
It's
surrounded
not
by us
possible here.
will
That
be
is the biggest
making more
disadvantage here.
uncomfortable.
So at lower
So in that
temperature,
case,
so the water will be coming
moderate
here.
humidity
So whatever
of
the
around
refrigerant
40
fluid
to
we keep it
50
here. So
percent
they given
is
it as 7
highly
degree, 13
desirable
degrees
for a
Celsius.
comfort.
So accordingly,
So any
so
air
it can able to
conditioner
extract the heat. So
would be
thus
operated
it
to
is giving its
maintain
cooling
the
effect here. So
moderate
in this way,
humidity.
so we
That
produce
is one thing.
the
This is all
refrigerating
about your
effect
air conditioning
in
part.
the vapor
So now the
absorption
basic
refrigeration
the
system.
difference between
So when
refrigeration
you
and air
compare to
conditioning
that,
is
your vapor
refrigeration is
compressor
always
system,
with respect
so
to
already we
the
have discussed
cooling.
it here. So we
No
cannot
heating
go
will
for
come
very
here.
low cooling
Air
in case of
conditioning,
vapor
both
absorption
heating and
system.
cooling, and also the
That's
maintaining the
exactly.
comfort
Even
condition. So in that way, we
especially
can
when we use
understand that
water, we
this
cannot go below
refrigeration
0
and air
degrees
conditioning.
Celsius
Now we'll get into
for
this.
this application system,
Now
because
we'll
water
see
will
the
be freezed
refrigeration part
when
now.
it goes
After
below
that,
0
we'll
degrees
pass on to
Celsius.
the
So above 0
air
degrees
conditioning
Celsius,
part.
in the range of 5 degree, 10 degree, moderate
So
cooling. If you want
this
to
is the
give a
definition
moderate cooling, with
that
the
we
minimum
are given
heat
here.
input,
So whatever
the
we have
energy
discussed
requirement
is
will
same.
be less here.
Defined as
So
a
in this
process
way,
by
we
which
can
the
able to
temperature of a given space is lower
achieve a cooling
below the
effect in the case
atmosphere or
of vapor
surroundings.
absorption system.
So the lower temperature
So
is
large
always
area has
called
to
as
be
a
cooled,
refrigeration.
okay, with a moderate cooling
So
effect.
the
So we'll
basically
adopt
these
this
are all the
vapor absorption
applications for
system.
the
Either it
comfort
is a lithium
conditions
bromide or
for
ammonia,
industries,
according to the
even
availability
for
of
preservation of medicines
the
or food
refrigerant we
products,
can use it.
even for the rocket fuels and all.
So this
Because
is
we have
the basics of
low
your
temperature,
vapor
we
compression
need
and
to
vapor
maintain some of
absorption
the rocket fuels.
systems.
For that, we need to
So coming to the
maintain
basic difference between the absorption
low
and
temperature,
compression system
isn't it?
here.
We call it as a cryogenic.
So absorption
Cryogenic is
system, as
again
we
it is
discussed here,
dealing with the low temperature.
the waste
Cryogenic
heat is
fuels,
less sufficient
so
because
that is
the heat
completely
input
related to
given
rocket
is
fuels, computer
relatively
functioning
less
also.
when we
You
use the
see that
absorption system here.
we always
So the
prefer
exhaust gas
our laptop or system
steams,
to be in
that
a,
is a
a
used
cold
steam.
place. In an AC room,
Utilized steam,
because it will not be
low
heated
quality
up,
steam can be
it can
used.
very
Even
effectively
sometimes
work
hot
it.
water can also be used
Suppose
in the ammonia
if it is
water
very hot,
refrigeration system.
so even we may
And then
feel
when
the
we
functioning of
go for
computer or
a
laptop may
compression
be
system, vapor compression system,
lagging.
this system will
That
not
we might
work
have felt.
without electrical
So in that
energy,
way,
because the
the
compressor is having
refrigeration,
the compressor
the
needs
cooling process
obviously
finds
a
application
high
in
grade
all
energy,
those
electrical energy is needed. So that's
places.
why
It's very
we call
vital.
it as a high grade energy.
Okay.
And also
Now
the power consumption
we
will
have
be
some
more
technologies
when we use
related
the
to
vapor
the
compression
refrigeration.
system. So
One
it is
is
a low
we
grade
call it
energy.
as
So
COP.
relatively, the economy will
COP
be
is
higher in the
referred
case
to
of
the
the absorption
coefficient of
system here.
performance. So we might have
So
studied in our
here
thermal engineering
almost
also.
no moving parts except pump
So
in
it
the
is nothing
absorption
but
system.
COP is
So here
nothing
we
but
have the major one
it is
is the
nothing but an
compressor here.
efficiency. Suppose for if we take
So
a
the
heat engine,
compressor,
we call it as a thermal
when it runs, it
efficiency.
is a
Just
mechanical
similar to
equipment,
that,
so it will
it
have
is
a
an
wear and
efficiency
tear.
of a
So we have
refrigerating
to
machine.
replace after some time. But here
So how effectively
it
it
is
works.
relatively less
So
here.
what is the
So the
definition of
running
that
cost
COP?
will be relatively higher in the
It is
case of
nothing
the
but
vapor
it is the
compression
ratio
system.
between the
The
refrigerating
system
effect
can
by
work on
work
lower
input.
evaporator pressure also without
Refrigerating effect
affecting the
means
COP here.
what
So
is the
even
cooling effect we are
when
getting?
when
The numerator will have
actually
a refrigerating
if you
effect,
see that evaporator, it is
and
a
the
low pressure
denominator
region.
work input, because
So the
we
changing
have
of
to for
pressure
a
will not much
refrigerator
affect in the absorption
refrigerating
system.
machine and
But
all,
here
compressor is that compressor
the
gets
COP
power
is
input.
greatly
We need to
depending
give the
on
power input,
the pressure,
so
because
that
correspondingly you
always
have the
it
enthalpy.
requires some input for
So that
refrigerating
enthalpy is
machine to work.
decreasing. So it may greatly
Because
affect
according to
the
our
COP
second
of
law
the
of
system. So
thermodynamics,
vapor compression
always
system,
heat may be
so
flowing from
it
high
is
temperature to
depending
low
on
temperature
the pressure on the system.
naturally.
But it is no way
But if
connected
you
to
want to
that.
transfer the heat from low
So that
temperature to high temperature,
even if it is working on
so
the
we
low
need to
load or
give
low pressure,
work
it will
input.
not much affect
So
the COP.
transferring
COP,
of heat
if you recall
from
that
low
one, COP is
temperature to
nothing
high
but it's nothing but
temperature is
efficiency,
nothing but
the
functioning of our
coefficient of
refrigerator.
performance.
So,
So you might have
so
studied
based
in
on that
thermal
law,
engineering one also.
for functioning of refrigerator,
You
it
see
needs some
that
power
even
input. That is
when
nothing
the
but your
load is less,
compressor gets
so it
power
will not
input.
affect its performance.
So
Here in the
more
vapor
the
compression system,
more the power
performance
input,
is affected in
lesser
that
the
load.
effectiveness,
So
because
in that
denominator
refrigerator
work
space,
input is that.
so the
So if the power input,
load
if it consumes more
which has
power,
been kept is
so
vital.
automatically
So
your COP
with
will be
respect to
decreasing,
that only, it
because
will consume
denominator
power.
is increasing, so COP may be decreasing.
So in this way only they are given this
In that
point
sense,
here.
so we
And
need to
liquid
design a
phases
system
refrigerant present in the
so that
piping and the exit of the
it
operator
requires a
constitute
minimum
load
power
input.
input. It
So this
consumes
is another
minimum power,
important point here.
so that our COP,
We have to always
COP or or
issue that
effectiveness of
in
the
case of a
machine
vapor
is
compression
better.
system,
There is another
the
terminology we
compressor,
call it as
the
a
refrigerant
relative
is entering
COP.
into the compressor
This is
after
nothing
coming
but
out from the
comparing
evaporator.
our actual and theoretical
Right.
COP.
So that is in
What
the
is
freezer
actual and
box.
theoretical COP means?
So in the
theoretical
evaporator,
COP
we have to
means by
design that
calculation,
so
by
that the
analysis, we
refrigerant
get some
should
COP
have
value.
either it should enter in the dry
Coefficient of
saturated
like a
state or
efficiency
superheated
value.
state.
So we'll get some
No
efficiency or
wet
COP value.
vapor should enter into
So
the
because
compressor
of some
a
losses,
vapor compression system.
our actual
Because if it
COP
enters with that
will be less than. So we'll
moisture,
compare
so it
that
may
one.
affect the
We'll get a
mechanical
relative
component.
COP. the thing is again the reason for having theoretical COP is without any loss
superheating and
we can understand how much we are getting.
In the previous class.
With loss, how much we are getting. So how we can improve the actual system, comparing with the theoretical one.
But
So
such complication will not arise because of
a reference. Will improve our actual
even though liquid
COP
traces
of
are present, it will not affect the
so in that way we used to find out the relative COP.
And then this automatic operation of controlling and capacity is easy
so
here.
We have
so
the experimental
it is nowadays we cannot say that it is relatively difficult. Even in the vapor compression
in
now
your
also relatively it is okay. Now we have
vapor
sensors,
compression refrigeration.
then we have thermostat and
I hope
everything
you
is there.
you would have done some experiment.
It is a balanced one. Vapor
Now
compression system
there is
it
another
is also
technology
having
in our
some
refrigeration. We call it as a
so this is the
turn-off
basic difference
refrigeration.
between your vapor absorption system
So
and vapor
turn-off
compression system.
refrigeration is nothing but
So wherever we
it
need
is a conventional term
the cooling effect
comes from
should be very high. If you don't want,
what
if you are
given it here.
if you are
It's
not
nothing but
considering
amount of
the cost,
heat
the cost
removed
is not important for us,
from the
but the cooling
surroundings,
effect
which
is
is
very
equal to
important.
that
We need to go for a very high
heat
cooling
required
effect.
for melting of 1 ton
We
of
have to
ice in
adopt
1
only
day.
a vapor compression system.
So
Immediate
from
cooling
that
effect will be
reference,
there,
we
but the
call it
running
as a
cost
turn-off
will be
refrigeration.
relatively high. Vapor
So that
absorption
equivalent
system,
value
we can
is in
go
terms
for a
of
moderate
SI
cooling.
unit
We cannot
is
go for below
3.5
0 degrees Celsius.
kilowatts.
And then
So
large
whenever we
area
go for
to be cooled with the
buying
moderate
AC
cooling,
and
then
all,
we can
we
go
used
for
to
absorption system.
call
This
how many
large
tons.
area cooling
The ton is
effectiveness
nothing
is
but
very
the ton of
important, like your auditorium,
we
mall.
prefer 1.5 or
All means
1
that
ton,
is also large area
1.5
only.
ton, 2 ton. That is nothing but
Theater,
your
mall,
ton of
and
refrigeration. How we
auditorium and
achieved
all.
this
It's a large
3.5
area
kilowatts?
where the
We have a
cooling
small
effectiveness
calculation.
we have to maintain a
show
very
you.
precise cooling, very low temperature means we have to go for
See
only
here.
vapor compression system only. So
Turn off refrigeration.
a large
So
area
the definition
cooling
was
is relatively
amount of heat required for melting of 1
moderate.
ton of
That
ice
means above
in
0 degree, 5 degrees Celsius, 10 degrees Celsius, just sufficient.
a particular day.
Then I can go
That
for
is
vapor
for 1 hour.
absorption system with the minimum running
You
cost.
see that
So
exactly
this is
for
the
1
basic
ton of
difference
ice,
vapor absorption and
it is precisely days 9.
there is another refrigeration system.
07 kg.
We call it as
a 1 ton.
steam jet refrigeration system.
So we have another parameter
So
called latent
it
heat
consists of
What is latent heat
it
of ice?
uses the
It is nothing but
amount
the
of flashing of
to
vapor
melt
concept.
ice from
It
0
consists
degrees
of
Celsius to
convergent divergent nozzle,
water at 0
eject
degrees
on.
Celsius. இந்த ஐஸ்
And
மெல்ட்
then
பண்றதுக்கு
it's
ஐஸ் மெல்ட்
it
ஆகும்
will be having
நம்ம எவ்வளவு ஹீட்
two
கொடுத்தா அது மெல்ட்
inlets.
ஆகும் அந்த ஹீட் this is
Your
standard
convergent divergent
we call it
nozzle.
as a latent heat of ice.
One inlet is connected
latent
to
heat
the
means there will
high
be a
pressure
phase change no
steam.
change in temperature that we call
Another
it as
inlet is connected to the
So,
low pressure steam, that
for
is low vapor. There will be
melting
two
of
inlets
ice
here.
for
Its
this
outlet
is
is
so much
connected
kg
to the
for
condenser here.
907 for
Further,
9000 for 900
the
kg
condensed
of
one
ice
will be supplied
so
to the
this
boiler.
much amount of heat has to be given for 1 kg of ice 1 kg
the
of
one
ice,
way
we have to
which
give
is
this
connected
much
to the
amount
low
of
vapor,
heat.
which in turn connected
for
to the blast chamber.
900 kg I have to
The
multiply
blast chamber is nothing but
and then
generally the blast chamber
for 1
is
hour
maintained at
for 1 day isn't it
low
so
pressure.
what I have to do it if I am dividing by 24
We need to
I'll be
understand
getting
one
for
concept.
1 hour and then I'll be
Suppose
getting
if I'm heating the water,
kilojoules per hour.
I'm
I
heating the
need it
water
for in kilowatts.
So the water will be heated
Hour, how do you convert hour into
normal
seconds? So I
room
divide it by
condition, that is the
3600.
atmospheric pressure.
So if
it
I am
can
doing
able
this
to operate
calculation, so I'll
only
be
at the
getting
100 degrees
for
Celsius.
1 ton of refrigeration. So my
because the pressure is 1 bar. So when the pressure is 1
corresponding
bar,
equivalent
we
value
can
in
able to
kilowatts.
operate the water
This
at
is our
100
SI
degrees
unit.
Celsius. That is
So I'm
boiling
getting
point.
3.51.
So the pressure changes.
So what is
Suppose
the
if
meaning
I'm
of
reducing
this
the
now 1
pressure
ton? Okay.
in a
What is the
confined
meaning of
atmosphere,
this? So it
like
can
this
enable
place, I'm
what is
reducing the
kilowatts
pressure,
kilojoules per
so
second.
the boiling point will be
Kilojoules
reduced.
per second only we call it as
Suppose for
kilowatts.
example, if the pressure is
So,
less than
1 ton
1
means
bar,
it can able to
0.5
remove
bar, 0.6 bar means the boiling point will be
3.5
well below of
kilojoules
100
of
degrees
heat
Celsius. So
per
that
second.
concept only we are using it
system.
here.
If it is 2 tons,
So what we'll do it here,
we can able to remove 7 kilojoules
we'll
per
have a
second.
high pressure steam.
So if the ton is
So which
increasing,
will be
the
coming
rate
from
of
the
heat
boiler.
removal.
So part of the steam, when it is this may be
be
used for the energy generation.
Rate
So
of
part of
heat
the steam will
removal
be
is
taking it,
important.
will be
Rate,
sending it
how
to
fast the heat is
your convergent
extracted
divergent
and it is
nozzle.
sent
So when
out.
it is passing it here,
So this is directly
so,
proportional
what
to the
will happen?
capacity of
So the
your,
steam will be
your
expanded
AC.
here.
For example,
So when it
take a
expands,
split
it may
AC.
create a suction here.
We take a
When
1
it
ton
expands,
AC, 2 ton AC.
it may create suction here. So when it
For
suction
example,
is
in a 10 by 10 room,
this will be
we fix
directed to
AC.
your flash chamber here. So
the same
what
10
we
by
do
10 room,
here by
adjacent to
expanding
that
here,
room,
we are
we fix
creating a
for
suction.
example,
Suction is nothing
you
but
can
low pressure.
fix a 2 ton AC.
So we create a low pressure here. So we'll absorb the
Assume that the room temperature is same.
We'll absorb the vapor here as well as
Initially, the
we
room
will be
temperature
supplying
is
the
some 35 degrees
water,
Celsius is
the
there.
used water from the air conditioned plant. This is air conditioned.
So we have set the
air conditioned
temperature in
plant
our
here.
remote.
So when we
some
evaporate
20
this,
degrees Celsius, 35
because
to
the low
20
pressure
degrees
is there,
Celsius.
so that quickly the water
one
will
room is
boil
having
here.
1 ton,
So when the
another
water
room
is
having
boiled
2
here,
ton with the
so
same space,
it may
10 by
giving
10
a some sort of cooling
Okay.
effect here.
So which room
So every
will
time
get
when the
faster cooling?
water boils here, so it may
Which room
able to give
will
a
reach the
cooling
20
effect.
degrees
For
Celsius
example,
faster?
we have a
Obviously,
100
2 tons.
kg of
Correct, Amma?
water inside here.
Yes, sir.
2
If
tons, 2
if
tons.
I can able
என்ன
to
reason
evaporate
அப்படின்னா
some 1
rate of
kg of
heat
water,
removal
so the
is
water temperature
this
will
is
decrease around
3.5.
5
இந்த
to
roomல
6 degrees
3.5
Celsius. We
kilojoules
have
per
a
second
calculation.
heat
Q
remove
equal
பண்ணி
to
வெளியே
mcp
எடுக்கும்.
delta. Okay.
Another
So
roomல
every time
7
so
kilojoules per
1 kg
second
of
heat
water is
remove பண்ணி வெளியே
evaporated every
எடுக்கும்.
time. So first time,
rate
first
of
1
heat
kg of
removal
water is
is faster
evaporated.
in the
So there is a decrease in
the
temperature
2
of 5
tons
degrees
is
Celsius. For example, initially the
quickly it
temperature
will
is
reduce
around
the
40 degrees
temperature,
Celsius.
it
So
will
it will
come
come to
down.
35
So that
degrees
is the
Celsius.
advantage.
Again, I am
So
evaporating
higher
another
capacity
1
tanks
kg
is
of
giving.
water here.
So
So
the
the temperature
cooling
will
effect
reduce
will
to
reach
30
positive.
degrees Celsius.
But what is
Again,
the
I am evaporating
disadvantage?
5 degrees like that. So
என்ன
we'll,
drawback மா?
every time
அதுல
when
என்ன
we
drawback
evaporate
இருக்கு?
this,
From our
Power
side,
so
consume
the
அதிகம்.
temperature of the
very
water
good.
will
அவ்வளவுதான்.
decrease
Our
here.
consumption is
Okay.
more.
So you can
So
understand by
it
using
can
Q
able
equal
to
to
extract
mcp
more
delta.
heat.
Okay.
Cooling
Q is
effect
the
fast
amount
வந்துரும்.
of
But it consume more power.
the
So if we are
evaporated
ready to
amount
pay
Q, mass of the water, and
for
Cp
the
is the
more power
specific of the
consumption,
DT.
then
If
we
you
can
put it, the
accept
DT
it.
will
So
be
in this
getting
way, we
it
can
as the
understand
difference in temperature
the
every
turn
time
off
around
refrigeration,
5 to 6 degrees Celsius.
the relation between our
So
turn
that
off
5 degrees
refrigeration and
every
capacity
time
of the refrigeration.
when the temperature
I
is
hope
decreasing, so the water temperature will decrease it here. So we'll not
we
allow
are clear with this
below
turn off
go below
refrigeration.
5 degree or 10 degrees Celsius.
So
So
more the turn
even
off
when it comes to
refrigeration,
15 degree,
the
10 degree
heat
Celsius, it is a
extraction
cold
rate
water.
is faster.
Right. So that cold
that
water will
particular
take
space
it
will reach the cooling
to the air
faster.
conditioned plant,
But
and then
it
so
consumes
that will be
significant
supplied
amount
like
of
your
power.
vapor absorption
So in that way, we
refrigeration
can
system.
understand that
5 degree, 10 degree Celsius, that cold
the
water
turn
will
off
be supplied to the
refrigeration. So I hope you understood.
like a vapor absorption system to
Then
that
there are
and
two
to the
types of
space where we
refrigeration
need
systems
cooling there.
is available.
After absorbing heat from that, it will become
Normally we use
a warm water.
One is
So warm water is
vapor
again,
compression
so it will be
refrigeration
coming
system.
here.
Another one is
So
vapor
we'll not just
absorption
supply it,
refrigeration
we'll just
system.
spray it by
Already
using
you
the
may have some
nozzles.
idea
The
about
reason
this.
is,
Anyway, we
so
are
we'll
going to
have
see in
a
detail
more
about this
physical
vapor
contact
compression
between the
vapor
water and
absorption
vapor
system.
here. So
Where we'll
when
use
I'm
this? What is the basic
when I'm
difference?
spraying in a very fine form,
Okay.
so the contact will be
Now,
more, so the
if
heat
you see
transfer
our vapor
rate will
compression
also
system,
be more, so that we'll be having effective
normally
cooling as
all
well
our
as the heat transfer.
domestic refrigerator,
So
our
here I am having a small amount of high
refrigeration
pressure steam
system we
and
use in our
large amount of
vehicles,
low pressure steam.
our
So both will be
split
mixed
AC,
here
all
and
is
then it is
working
sent
on
to the
the
condenser.
vapor compressor.
So we use some external cooling
It
arrangements
consists
here,
of mainly
so that
4 primary
steam will be
components. One is compressor,
converted. That is, it is vapor. It is in the vapor form. It is
condenser,
converted into a water here.
expansion
Again, it
valve
will be
or
sent to the
throttle
boiler
valve,
here.
and
So in this way,
evaporator.
your steam jet
These are all the
refrigeration
4
system
prime
is
components,
working here.
without
You
which
see
the
it
system
here.
will not work.
So
In addition to
we are
that, we
not
may
using
have
any
other components
compressor,
also,
or
that
we
is
are
an
not using
auxiliary
any heater,
equipment. But without these 4
generator
components,
like in
the
our
system
vapor
will not work.
absorption system or vapor compression system.
Compressor,
So only
condenser,
we use a
expansion valve, and evaporator.
yeah,
So now let us
steam.
understand
Yeah, we need a small amount of
how
high
the
pressure
system
steam.
is
Low
working.
pressure steam is
So you
not
may have
possible.
some idea.
A high quality
But
of
we
steam,
will
even a small amount is possible.
with
Small amount is enough.
with
So
some
that steam
theoretical concept
we
and also
supply it
with our
here,
thermodynamic
and then
problems also.
when it expands
Any
here,
vapor
so
compression refrigeration
here the
system will
suction will be
consist of
created,
a
so that low
refrigerant.
pressure vapor can be taken.
Mainly, colloquially we
Both
call
will
it
be
as a
mixed
gas.
in
A
So
refrigerant.
here we do a
we
dual
have
purpose
refrigerant
here.
of
We are
various
taking a
kinds.
low pressure vapor as well as, so by
We call it as the R12, R22.
taking away this, so we
the
extract the
R134A,
heat.
ammonia.
Here is a low
Like
pressure
that, various
equipment, fast chamber. So
refrigerants are
immediately,
available.
so the vapor will be generated. The
The
vapor will be
refrigerant,
taken. So the
will
vapor is
undergo a
being generated every time. So the water
various processes
temperature
in
is
all these
decreasing.
4
So we are
components.
achieving a cooling
So
effect.
it is
We
a
are getting a
cyclic
low
process.
pressure vapor here.
So I can
Low
start
pressure
anywhere.
vapor will be used
We
here.
can,
The cooling
because
effect
I can
achieved.
contain
That
anywhere
cold
here.
water will be
Being a cyclic
used in the
completely
air
closed
conditioned
system.
plant. So in this
Normally we cannot be able to see that
steam refrigeration
in any
system.
refrigerator or any
This is all about
refrigeration
our
system.
refrigeration
So it will be,
system, vapor compression, vapor
it
absorption,
will be at the rear,
steam
or
jet
it will be it would
So
be
this
hidden.
also
So you
we
able
cannot
to
use
see
it in a household appliances and all,
So
because we don't have boiler or steam and all.
exactly what is
So
happening.
this is again industrial cooling
so in the
system. So wherever
evaporator,
we have the
your refrigerant
a steam supply
will be
boiler
come out
arrangement
in
is there.
hot
Then we can adopt
condition.
this steam
So
jet
evaporator
refrigeration
is nothing
system.
but your freezer box. In our refrigerator, if
So
you take
next
our
we
freezer
pass
box,
on to
that is
the
nothing but an evaporator.
air conditioning system.
So the
Here.
refrigerant, it is a closed system. The
So in
refrigerant
our
will come
very first
out
class,
in
that
the
is
vapor
vapor
form.
compression vapor refrigeration system. So we were discussing about this refrigeration system and the air conditioning system. So refrigeration system is always we talk about the cooling. Right? So air conditioning system is nothing but
The hot
is
vapor refrigerant will enter into the
cooling as well as
compressor
heating
here.
also will be there.
So the
in addition
compressor
to that,
will further
will
increase
maintain
its
the
pressure and
moisture
temperature.
content, that is humidity of the air also. So
So the
because
pressure
that
and
is
temperature
also
of the refrigerant
important
is
for
increasing.
maintaining our comfort.
So it is in the vapor form only.
Okay, that is
So that
also
refrigerant,
important for
the
maintaining
high
our,
pressure, high temperature
comfort.
refrigerant
Because,
is entering into
there
the
are three
condenser here.
cases.
We use some external cooling arrangement.
Low humidity,
If it is a large
moderate
capacity
humidity,
refrigerator, we need
high
to use a
humidity
fan
is
and all.
there.
If it is a small capacity refrigerator,
So
no need
low humidity and high
atmospheric,
humidity will not be giving
that-
comfort for us. So only
air is
moderate
just
humidity will be
sufficient.
giving comfort for us, because in the high humidity. So
On the hot
what is the meaning of
refrigerant,
humidity?
which is at high
Already we have
pressure and
discussed. Humidity
temperature,
is nothing
which
but
we enter
amount
into the
of moisture
condenser.
content.
Condenser is nothing but a heat
So
exchanger.
higher the
We'll have a number
humidity,
of
more
tubes.
moisture is present.
We
in
might
the
have
air.
seen
So during sweating,
just like
so the water will not
a tube,
evaporate from our body
bend the
when
tube in
it
the
is
rear
the
of
high
our
humidity.
refrigerator.
So we'll be feeling highly uncomfortable.
Yeah. So that is our
And if it is a low
condenser.
humidity means,
Air side
so air will be
ஒரு
so
grill
dry.
மாதிரி இருக்கும். That is our condenser, through which our refrigerant
Again,
is
we
flowing.
will be feeling like
So
in the
here,
desert place.
the
So
vapor
we'll be feeling
refrigerant is
uncomfortable.
converted
So moderate
into
humidity. So we'll call it as a
liquid
relative
refrigerant,
humidity. We are going to see.
because,
So the relative humidity
we
of 40
extract
to
the heat from that
55% or
refrigerant.
60%
So there will be phase change
giving
here.
comfort in the air
So
conditioning
during
space.
that phase change,
Then the relative
since
humidity
the
is
phase
80
change
or
is taking
90%.
place, almost the temperature,
So what
theoretically
will
the
happen?
temperature remains
So
constant.
during sweating,
If it is
the
in the
water will not
superheated
evaporate
state,
from
will
our
reduce
body.
to the
So
saturated
we'll be
state.
feeling highly uncomfortable.
After that,
so the humidity control
phase
will
change
be
will be taking place.
taking place only in the case of a
So
humidity
in the
control can be
outlet
done
of the
only in the case
condenser,
of
you
a
have
air
a
conditioning
cold
system alone.
refrigerant will be coming.
In addition to the temperature
the
control, either it is a
refrigerant which
heating
is
or
in the
cooling.
liquid
such
form will be
systems
coming
we
out
call it
here.
as a air
Not a
conditioning
cold
system.
refrigerant, a warm refrigerant.
So these are all some of the
Refrigerant in
applications
the liquid form. It is
for
vapor
our
form.
comfort,
Here it is in the liquid
for
form.
our industrial
It will enter
purposes,
into a
and for our
expansion valve. Expansion valve is
commercial
we also call it as a
either
throttle
mall
valve.
or big auditoriums.
Exactly,
We use
what is
this air
throttle or
conditioning
expansion
system.
valve means? It is a
There are two types
very
of air conditioning
restricted
system.
passage.
One we call it
For
as
example,
a summer
if
air
you take
conditioning system.
yeah,
Another
already
one
we
is
have
the
discussed
winter air
one day
conditioning
one.
system.
So if you take
Summer air
a
conditioning system
restricted passage,
involves
assume that our tap
cooling and a
our water tap
dehumidification
is
process.
close to almost 90%.
So
We are
in
close to
the
water
summer,
tap. We have a small space.
we need cooling.
A small
so in
opening.
the dehumidification presence,
Having a
so
small
more
opening,
water
if
will
I
be
am allowing
evaporated.
this,
So that air will be having more
liquid
moisture
refrigerant
content. So we
to
have
pass
to
through
remove the
this.
moisture
So it will
content.
be
So that's why we use
coming to a very
process called
restricted small passage.
dehumidification.
That is very small
Humidification
diameter.
is nothing
tube
but
will be
adding
there.
the moisture.
So in that way, we can assume our
Dehumidification we call it as a
our
removing
expansion valve or
moisture
throttle valve
content
here. So when it comes through a
and then in
restricted
the case of
passage,
a
there
winter
will
air
be huge
conditioning
pressure
system,
drop.
so
So
obviously
always
we
there
need
will be
heating, and
already
also we
the
need to
pressure
give
has increased
some
here.
moisture.
So it is a high
So
pressure
this will be
refrigerant,
carried out
the
by
liquid
air
form, which
conditioning
is coming
system.
through
When
this.
it is
So when it
combined
comes through
both summer and winter air conditioning
a
system, we
restricted
call it
passage,
as
very
a
small,
year-round
very
air
very small
conditioning.
diameter, maybe 1 mm,
Now
2
let us
mm,
see
2.5
that
mm,
that
so when it passes through
the
this,
working,
so
the
there will be
basic
huge
components
pressure
layout
drop.
of this air
So
conditioning
because
system.
of this huge pressure drop,
So if you see
immediately
this
there will be
summer
a
air conditioning system,
temperature drop will be there, because pressure and
so
temperatures are
it
directly
consists
proportional.
of basically
So because
you
of
have
that, there will be a
you
huge
have a duct
temperature
will be
drop.
there,
So immediately
and
we'll
then
get a cooling
mainly it
effect here.
consists of an air filter.
Even if we just fill it
We'll
here,
have a cooling
it will
coil
be so cool.
and water eliminator and
The
heating
reason
coil. This is the major
there
equipments
is a drop
in addition to
in
the
pressure
blower
and corresponding
in the case of a
temperature.
summer air conditioning system.
So here only we are getting a
So,
refrigerating
for
effect.
doing this in
So the
summer
cold
air conditioning
refrigerant,
system, we have
the
to do the
liquid
process
form,
of
which will
cooling and
enter into the evaporator, your
dehumidification. This
freezer box.
process we have to
If
do
you
it
closely
here.
observe our
So
freezer
for
box,
that we'll take an
so you might
atmospheric
have
air. So
seen,
this will be
just
passed
like a
through a
tube
damper jam.
surrounded
Nothing but a
in the freezer
controlled way
box
of allowing
inside
the air
some
here.
hollow
Just like
tubes,
plates,
a square shape or rectangular shape,
plates.
you might have seen.
So we can able to
So through this,
control the air
our
flow
cold
here.
refrigerant in
So
the
when it
liquid
passes
form will
through
be
this
flowing.
air filter,
So whatever the
will remove the
load, we keep
the
it
dust
inside.
particles and foreign
So that is
particles
hot.
in the air here. So
Because
when
it is a
passing
cold
through
refrigerant,
this cooling
for this
coil,
it is hot.
this cooling coil
Maybe
is
even in
nothing but how do we get
temperature,
the
it is
cooling
hot
effect in
only.
the cooling coil?
So when it
This
flows
is nothing
through
but
this,
your
so there
vapor
is a
compressor
temperature
refrigeration
difference
system.
between the
So we'll have this
load and
compressor
this
expansion
refrigerant.
valve.
Refrigerant
This is
maybe
nothing
even
but your
sometimes
evaporator.
-2 or minus
The rest
3
three
degrees
equipments
Celsius,
you will be
even
having
minus
it
5
here.
degrees Celsius also.
That way only our air conditioning system is working.
So here
Compressor,
the load may be at
condenser,
30 degrees
expansion
Celsius
valve
or
will be
35
there.
degrees
The
Celsius, so the
refrigerant will
temperature
be
difference is
supplying
very
here.
high.
That's why
So
in the air
immediately the
conditioning system
refrigerant
and
will
all, we
absorb
use
the heat from
refrigerant
this.
and
Immediately, so it
everything we
gives
are
a cooling
using it
effect.
here. because this cooling coil is
So
nothing
when
but
the
a very
refrigerant is
evaporative
absorbing
refrigerating
heat from
space.
that, the
So when
refrigerant
that
vapor will
cold
be converted
refrigerant
into
is
a
passing
liquid
through this,
because there is a
so
phase
the air
change
will
here.
be passing here. So what will happen? So there is a terminology called dew point temperature. So dew point temperature of air is converted into a vapor form when it absorbs heat from the load. At one point, the moisture content
So the vapor
air will start to condense.
again will enter into the compressor.
That point we call it as the temperature.
Start
At this
here,
point we
we
call it as a dew point temperature.
Again, we end here as a
There
vapor.
are three things: dry bulb, wet bulb, and dew point
vapor
temperature. Dry bulb, wet bulb we see
is working.
So the dew point temperature means
cooling effect.
So when
the
we
same
have
process
the air water
represented in our
and the air
pressure
is
enthalpy
containing
diagram
water
and temperature entropy
passing it
diagram.
through the
So the
when
1
I'm
to
just
2
cooling
process,
it.
we call it as a
When I'm keep on
isentropic
cooling
compression.
it, at one point
is taking place in the compressor.
it may that water vapor
Always
percent, it
the
may be first it
compressor
will be in the
expansion
superheated
process,
state,
call it
but
as
after that it will come to the
entropy
dry
remains
saturated
constant.
state. When it
We
reaches the
observe
dry
our
saturated
pressure
state, at one
enthalpy
point
and
it may start to condense.
TS diagram here.
So that
So
starting
1 to
point
2.
of condense we call it
So
as
temperature is
the
increasing,
temperature
pressure is
at,
increasing.
the point where
it is rising.
vapor condense we call it as
pressure
the
and
dew point
temperature is
temperature.
increasing.
So
And the
our
entropy remains
refrigerating
constant.
coil,
Vertical
that
line,
is the
so
operator
entropy
coil
remains
will be
constant.
designed to
This enthalpy
operate
is also
so that
increasing here.
the air which is
Coming
passing
to our
through
2,
will
3
be
process,
cooled to
our
till
2,
the
3
dew point
process,
temperature.
you see it here, the
So
pressure
when it
remains
reaches its
constant.
dew point temperature,
Right.
so
Actually,
what
there
will
will be
happen?
some pressure
So
drop
the
will be there.
water vapor
Practically,
present in the air will
theoretically,
start to
assume it
condense.
as
This is the
some
process of
pressure remains
removing the
constant
moisture
here.
content in the
So
air.
here, the temperature is also
So
remain
we will
constant
have the
when the phase changes occurs.
air will
But
be
if you see
passing.
it here,
So we cannot
2 to
able
3
to
that
drain
here
all
the
the water
temperature is
here
dropping
immediately because
drop
it is
is
flowing
taking
here.
place.
So
After
that we
that,
use the water
temperature remains
eliminator
constant. The
here,
reason is
just like
this is our saturation line, like our
screen like a
Mollier
structure.
chart.
So when it
This
passes
diagram,
here,
this is superheated
so
state.
we'll remove
This is
the
superheated state
some amount of
and
water
this is
here.
saturated state. This
So
is
that in
nothing
this
but
way
wet
maybe
condition.
around 90,
So
80 to
always
90% of
our
water will be
refrigerant
removed
will be in
here.
the
So
superheated
rest
state
of
after
the
coming out of
air
the
will be
compressor
passing
here.
through this here. Okay.
So we have
Suppose
to
because
cool
of
it
this
from
cooling,
superheated
the
state
air
to the
temperature is
saturated
reduced
state.
well below
Once
the
it comes
designed
to the
temperature.
saturated state,
Okay.
after
So we
that
can enable this
we cool
heating
it
coil
further.
to achieve a
So
required
it will be
temperature.
converted into
For example,
a
if the
wet
required
region,
temperature we have set
and
it,
liquid region.
the required temperature
That's why
is
here the
around some
temperature is
20 degrees
decreasing.
Celsius.
After that, phase change is taking
In that
place. The
condition
temperature
space.
remains constant.
So because of
In
this
this way,
cooling,
we can
the air
understand
temperature
our
is reduced
2,
to
3
18.
process.
So this will be enabled
we call it as
with the
a
help of
constant
sensors
pressure
so that we can able to get a required temperature here.
after
around
entering into the
exactly 20
expansion
degrees
wall.
Celsius.
So what is
So for that
happening?
only
So
we use this heating coil.
we
Otherwise it
understood
will not
that
be
there is a
enabled.
huge pressure drop, so that we
So
can
this
see it here. The pressure is dropping vertically
the
downwards.
cold air.
So there is a huge pressure
In the
drop
summer
here.
air conditioning
When there is a
system,
pressure
so
drop,
with the help of a blower,
corresponding
so it will be
temperature
taken
drop
to the
will also be
condensing
there. So it
space.
is coming
So in
vertically
this way,
downwards
your
here.
summer air
During this
conditioning
process,
system
we
is
assume it as
perfect.
enthalpy remains constant, but there will be a small change in
Coming to
enthalpy.
the winter air
Theoretically,
conditioning
assume it as
system here.
enthalpy constant. So that's why the vertical line is
In the case
vertical
of a
here.
winter air conditioning
Entropy is
system,
constant.
so what is
This
the
is
process
vertical.
to be
Enthalpy
done?
is constant. This is vertical here.
So we have to do
Coming
the
to our
heating and humidification process.
our
So
evaporator
that process
4
will
on
be
process.
carried out
This is
with the
also
help
heat
of
transfer process.
a winter air conditioning
Always the
system.
heat transfer process is constant pressure.
So
either it is a heating or cooling.
If you
This is
see
nothing
the
but your,
arrangement here, so we'll take
heat transfer
atmospheric air.
process, that
So
is
this
2,
will
3
be
and 4
allowed
on
through a
So in
damper.
the 4 on
The
process, what
controlled
is happening?
airflow will
It
be
is a heat
controlled
transfer
here.
process. It is
So we'll
absorbing
use
heat from the load here.
a filter
During
to
this
remove
process,
the dust
again,
and
the
foreign
pressure
particles
remains
inside
constant
the air,
as well as the
and it
temperature
will be
is also
supplied to
constant
the
because the phase change is
preheater.
taking place. Whenever a
So we'll
system
just hit the air.
undergoes a phase change,
That's
there
why
won't
we
be
call
any
it as
change
a
in temperature.
preheater.
So in this way, we can
After that,
understand the
it will be passed
thermodynamic
through a
process of
humidifier.
vapor
So
compression
we need to
refrigeration
add the
system.
moisture content here. So how the
So the 1 to
humidifier
2
is
process
working?
represent in the
So,
compressor.
the one
2
way
to 3
is
process representing
what
in the
we'll do it
condenser.
here. We'll have a
3 to
spray
4
nozzles,
process
water spray
represented in
nozzles
the
will be there.
expansion wall.
So in the
And 4
automized
to 1
way, we'll
process
just
which is
spray the
represented in the
water
evaporator.
with the help
We
of
need
a
to
nozzles
conversant
here.
with
So
this
when the air is
because we need to
passed
solve
through.
problems
So in
on
this way,
vapor
when it is
compressor
being
system.
sprayed
So
here,
for that,
we are
the
just
condition
adding
of
the
refrigerant will
moisture
be given.
content. We are
So
humidifying
we
the
should
air.
know how to
In this
represent
way,
all
the air
those
will
things,
be
and also we should know
humidified
the
to the
thermodynamic
required
process.
amount, and
Accordingly,
then it will be
we'll have to
applied
solve
to
the
the
problem.
preheating coil.
For
So
that,
why we
for
use
that
this
only,
preheating coil?
we
So
have
because of
seen
the
in detail
when we
pH
supply
diagram
the
and TS diagram.
when we
It's all
add
about
the
your
moisture here,
vapor
it's
compression
nothing but some
refrigeration
sort of
system
cooling
here.
effect will be there. Am I right?
Now,
So because of this, the
in
air
the vapor
temperature may
compression
decrease.
refrigeration
So if it is
system,
decreased
we have
below the required, so then
another
we'll enable this reheating coil then the air temperature
effect called
the required level.
superheating and
So in this
subcooling.
way, we achieve in the winter
Superheating
air
and
conditioning system,
subcooling.
we achieve the
So what is the
heating
meaning
and
of
a
superheating and
humidification
subcooling
process,
here?
so which is
Now
required.
I'm
So
coming
by
back
using
to
a blower,
our
we it will be
original
supplied to
system
the
here.
condensate space. So in this
So
way, our
if you see
winter
here,
air conditioning system is working.
this is our
Coming to
saturation
our
line. This is
central
our
air conditioning
superheated
system.
region.
So
This
this
is our
is
wet
nothing
region
but your
here.
year-round air conditioning.
Generally, what will happen?
So in the case of a central air conditioning
practical
system,
case,
we'll have both
when the refrigerant,
both
this is
process
in the
can be done.
liquid form.
That
When it
means
comes out here,
it can be done
it is
for
in the vapor form here.
summer air conditioning system
So the
as well as
refrigerant
for
in the vapor
winter
form
air
will be
conditioning
entering
system.
into the compressor.
And also we call it as a central air
We cannot
conditioning
expect
system.
if it is
Another reason
if it is a
we use
normal
the word
functioning of
central
vapor
means.
compressor.
So in a very small condition space means we can
refrigerant may
fix
not
this
be
system.
heated
Okay.
to a sufficient
So
level.
like our split AC
So it
and
may
all.
not be a dry
But
or
if it is a
superheated
very
state,
large
some
place,
moisture
a
may be
mall or
present
a
in
theater
that.
or
So that
auditorium,
means, so the
what
refrigerant will
we'll
be
do
entering
it,
from
we'll
this
have
point
a
itself.
large
There is only on the
cooling
refrigerant
plant,
dryer.
AC
The
plant
region
at
for
one
normal.
point.
There may be a possibility practically.
With a larger
So if
capacity.
this is the case, then what will
That,
happen? It will spoil the compressor.
cooling effect. The cold air
So
will be
no
supplied
moisture
via
or water
ducts to the
droplets
various
or
places.
moisture contents would
So that is the cooling
should
is
enter
taking
into the
place at
compressor.
centralized one place, and it is
So it
supplied
may-
to the duct
it may
through
affect
the
the
ducts to the
performance or
various
the malfunctioning of
places
compressor
in
mechanisms.
a big
Water
shopping mall
droplets
and
will
auditorium and all.
so
We call it as
compressor
the central
function
air
will not be
conditioning
proper.
system.
So it may affect
So
the
in this way
performance
we
of the
have the
compressor there.
initially we have
And
the
then,
filter here. We call it as a self
We have to
cleaning.
ensure that at the outlet of the
The
compressor,
self cleaning filter, the meaning is we can understand. So after
we cannot
some time
expect
when
in
we
the
use
normal
it sometime,
functioning,
so
we
your
cannot
dust
expect
particles will be
superheated.
clogged.
Dry saturated
What we'll do it,
compressor.
so here we'll have the arrangement.
If
we'll,
this is
we'll
the
give
case
just
here, then
jolting
we
or
have a
vibration
problem. It
effect
may
here.
enter in the wet
Okay,
region.
so that
So for that, we have to ensure
using of
that
some time.
always
So your dust particles will
dry
be
or
collected
superheated
here,
state
when
is
we are giving
achieved
a
at the
jolting or
outlet of the
vibrating
operator.
effect here. So that will be
Superheated
collected
state
here.
is
Some
achieved at the
around some
outlet
80
of
or
the
90% dust
If
particles will be
superheated
collected
state,
here. If you want to still remove it, the rest of one, we have to remove it no other way.
not possible.
Instead of removing every time, so we use this self cleaning type.
Point one reach
so most of the dust
So
particles
dry
will be
saturated
collected
state
here.
below
And
dry
then we have another filter here.
So in the
So we call it as a secondary filter. It may be electrostatic
so
type
the
or
moisture
fabric
present
type.
and then
So it will be
fine
for that finer
what
than the
we'll do is
previous one.
we have
So
to
the very
ensure
fine
that
particles can also be filtered here.
We forget about this.
So we have a
You
tempering
take
coil.
our
It's nothing but a
compressor,
heating coil.
condenser,
So if you want to do the
expansion wall
heating
and the
process,
operator.
we can use
Normal,
this coil here.
which we have
And
seen
then
in
this
our
is nothing but your
compressor,
chilled water cooling
condenser,
dehumidifiing coil. This is
expansion wall
nothing
and
but
the
your
operator. So
cooling
what we do
coil
it here,
so we
we do
have
a superheating and
this
subcooling
only will be
process.
connected to the vapor compression.
So that we have to ensure
this
that
system will be connected to the
at the outlet of the operator.
refrigeration
Okay,
system.
this is our.
So this is nothing but
what is the point
evaporator.
here? Outlet of
This
the
is nothing but
operator,
your
6
cooling
points.
coils.
Okay, when it comes out here, we
So when
further
we pass
heating,
this
so it is coming to
refrigerant
the
or
superheated
chilled water
state.
through
The
this,
region on the superheated region.
so
we ensure
we'll
that it is
allow
in the
the air
superheated
to
state.
cool to
Entry
the
of the
dew point
compressor
temperature. So we'll remove the moisture content
If
present
the
in
entry
the air,
itself
so that
superheated means
the
after
vapor will be
compressing, definitely pressure and
condensed.
temperature.
So we
will increase.
remove
Definitely this will
the
be in the
moisture
superheated
present in
state
the air.
only.
That's why we call it as
We'll
a
ensure that.
dehumidifying.
Okay, this is one point.
And then this is nothing but your
superheating.
air washer. Air washer
Now
is
coming
nothing
to
but
the
your
subcooling.
humidifier. So air
What
washer is nothing
cooling
but
now?
we'll just
So
spray the
here,
water.
again, I am coming back to our
one way we call it as a we'll just
standard
spray
refrigeration
the water
system.
in a
Here,
high velocity.
it is
so
a
that
condenser
the dust
here.
will be removed.
So we have
As
seen
well
that
as
at the outlet of the
add the
condenser,
moisture. That's why we
all
call it
the
as a air washer.
your
Air washer is
vapor
nothing
is
but a
converted into
humidifier.
liquid. So a
And then
process.
when we adding the moisture
saturated liquid
here,
state,
when the moisture is
Kirkalama,
more, so we use
critical
the
point, saturated liquid,
so
the saturated
suppose when the
vapor line.
water
So it
droplets
has to
are
reach the point
the water droplets are
Suppose
here.
if
Actually, moisture is added only in the vapor state only.
in the point line drop.
So the more moisture is added when it is in the drop,
all the
droplets
refrigerant
will
is
pass
not
it through the
converted
eliminator.
completely into
Eliminator is
liquid.
just like a
Some
mesh like a structure.
Some refrigerant in the vapor form. Vapor form
Otherwise, we have a zigzag passage. We have a perforated plates. So all those will be the arrangement of
wet region.
So when the air with
refrigerant
the water molecules will be
may also enter and combine with the liquid.
So that will be
some vapor
condensed.
mix.
Otherwise, that will be
If that is the
taken
case,
through
what
this
is the
eliminator.
effect? What will
So that
happen
will
means
have a
here the flow will be
the air
obstructed.
will be passing through
If
this.
completely
without,
liquid means the flow may be
water
there,
water
but
molecules in the air.
The vapor
may
block
present,
the
but
path.
water molecules
Also, there is
removing
a
in the
phenomenon
eliminator.
called
So when it goes to the reheating
vapor
coil,
starvation.
because
There may
of
be
this humidification
in the
in the
expansion
air
wall.
temperature
So
is
that is
reduced,
due to
so
that,
this reheating coil will be
refrigerant
enabled
which is entering into the
so we can able to attain the
expansion wall.
required temperature.
A combined vapor liquid
So
here pure liquid
when it is for a summer air conditioning system,
get a sound as
so that corresponding we
So
need
that we call it as
cooling
the
and
vapor
dehumidification.
starvation. The
So
flow
the
of
rest of
down
the
that
equipments will
So
be
the expansion
disabled.
wall will not
When it is
function
coming for
properly,
a
will not get a
winter air
proper
conditioning system.
expansion here.
So we need cooling and
the COP
dehumidification. Those coils will be enabled. So correspondingly, with respect to that summer and winter air conditioning system, that respective equipments will be enabled. Rest of the equipment will be disabled here. So in this way, you can use it for both summer and winter air conditioning system. So that's why it is a year-round central air conditioning system. Then it will be taken through a blower or fan to the condenser space by alternating.
I'll change the network.
In this way, our central air conditioning system and also the air conditioning system is working. So combined way, we can use it for both summer and winter air conditioning system. So this is nothing but our vapor compression refrigeration system. It is conventionally we were using this window air conditioning system. So the window air conditioning system is consist of your vapor compression system.
So we have to ensure at the outlet of the condenser, we need to have a pure liquid that is entering into the expansion compost. For achieving these two, we need to do the two processes called superheating and subcooling.
And we'll have the
superheating is to ensure that movement. Repeat again. Superheating is to ensure that
to take the
vapor is
and also
completely dry when it is entering into the compressor as well as when it comes out through the compressor space.
So this is the arrangement of
vapor will be
working is
your refrigerant will be pure vapor. And the condition
so if you compare, if you see your split AC system,
subcooling
will not
is
have like this separately. All the components will be separately fixed.
Our refrigerant,
so the condenser is everything is fixed in one place. In the case of window air conditioning,
pure liquid or mixed liquid and vapor refrigerant.
See our split air conditioning,
we use
separately we'll have a condenser.
This condenser is normally placed while designing a
so in the sanction and all it should have been placed.
For that, there will be a slight modification in the existing system of vapor.
The advantage, if you see that,
that will provide a small
have a high
heat transfer
throw
device,
also
heat exchange device will
able
use
to.
So now let us see that how it
window
works.
air conditioning system.
The usual way,
cold
your
air
refrigerant
supplied from only one
coming
place.
out from the
the distribution will not be that much efficient.
So it passes through a small heat exchange.
The window air.
So if you see it here,
this is not in your syllabus.
There is a
understanding purpose.
another way. Refrigerant is coming out from the condenser. It will be very
window air
condenser
conditioning
வெளியில வரும்போது refrigerant
and then this is the terminology.
Actually it is vapor. It is converted
in
cold
psychrometry.
I mean vapor refrigerant is converted to liquid refrigerant.
Psychrometry is nothing but
same hotness hotness குறைஞ்சிருக்காது. ஏனா phase change தான் நடந்துருக்கு. அப்போ
air water vapor
liquid refrigerant is coming here.
As a psychrometry. Air water vapor.
Here a vapor refrigerant is passing. அப்போ இங்க வந்து
hot because we need to
cold
the humidity
heat transfer
very precise level.
Now
for that we cannot just
heater will
get trial and error. So we have to
heat this
logically
when it gives this heat, this is
how do we
this will become cold.
That we have the
so
equation.
mutual heat transfer is taking
that
place.
equation
in the place
and after
what we did it here.
Technologies.
The refrigerant is coming out from the evaporator should be heated. Adha nammaloda concept. So heat ஆகும்போது it will become vapor.
Moisture is
the refrigerant is coming out from the condenser should be further cooled so that there should not be any vapor. So it should be completely liquid form.
Humidity level.
So both will be
increasing
combined in
more and more
heat transfer device here. Small
saturated air is
heat
nothing
exchanger மாதிரி இருக்கும். So இங்க heat
is
exchange
having
is
a humidity of maximum.
So your refrigerant is giving its heat here, so it is cooled.
Of 100%.
When it gives heat here, it is
completely
air is heated
with the water.
So that this 6-1 process heated we call it as a superheating process.
Water molecules
And
no
the
more
3-4
water will
process
evaporate.
this cooling is taking place. So that we call it as a cooling process. We call it as a subcooling. Subcooling
relative humidity.
So we are already here it is cooled. Further it is cooled down. So we call it as a subcooling. Already it is heated here. Again further we heating it. That's why we call it superheating.
Mass of
so in this way by using a small heat exchange yes
air in the saturated condition.
3 to 4 இருக்குல
denominatorல saturated condition ல moisture இருக்கும் numeratorல எவ்வளவு amount of moisture
heat எடுத்துக்கறாங்க
so அந்த ratio போடும்போது you will be getting
6 to 1 ல
denominator வந்து maximum saturated condition.
இல்ல 6 to 1 ல என்ன 6 to 1 ல என்ன எப்படி இருக்கும்னா ரெண்டுக்குள்ள டெம்பரேச்சர் இது வந்து ஹாட்டா இருக்கும் இங்க இருந்து வெளிய வரும்போது ஏனா ஆல்ரெடி
so will be getting relative in terms of
is extracting heat
so in this way only
evaporator தான் வருது இது வந்து வேப்பர்ல வருது இது வந்து எப்படி இருக்கும்னா
low moderate and high humidity so 10% 0.1
இந்த இடத்துல ஹாட் தான் இந்த இடத்துல ஹாட்
is the low humidity so 40% 0.4 the amount of moisture present is 140%.
இந்த பாயிண்ட்ல தான் நம்ம சொல்றீங்க
is moderate.
The point when
it is 90 or 90, we call it as a higher humidity. For calculating the amount of moisture content, immediate information will be getting. So that only we call it as a relative humidity. Important terminology. So we have an equation to calculate this relative humidity and all. And
உள்ளயா வெளியிலயா?
இப்போ 3 to 4
we
இருக்கா
can
சார்?
understand this psychrometry
3
with
to 4
respect to the
லைன்
three
இருக்குல்ல?
temperatures, namely
எக்ஸ்பென்ஷன் வால்வுக்கு
dry
பதிலா
bulb temperature, wet bulb
அந்த
temperature,
லைனும்
as we have studied our
6
dew
to
point temperature
1
earlier.
அதாவது
Dry bulb temperature
கம்ப்ரஸருக்கு
is
போற
nothing
லைனும்
but
நியர்ல
a
தானே
normal
இருக்கு.
normal
அப்போ
thermometer we
எவாபரேட்ல
measure
இருந்து
it,
வர
that we
அந்த
call it as a dry bulb temperature.
நியர்ல தான் இருக்கு. அப்படிங்கும் பட்சத்துல
There is
கண்டென்சர்ல இருந்து ஆல்ரெடி
here we
ஹீட்
use
ரிலீஸ்
the
ஆகி
wet
தான்
bulb,
வருது.
that's why we
இந்த
call it as,
எவாபரேட்ல
instead
இருக்கிற
of just calling it as a temperature, we call it
கொஞ்சம்
as a
ஹீட்
dry
ஆகி
bulb
தானே அந்த
temperature.
இது
So
வேப்பர்
the wet
வருது.
bulb temperature is
அப்படிங்கும்
nothing but
பட்சத்துல அந்த கூலிங்
when the same
இது
thermometer is covered with a
லிக்விட்
wet
வந்து
cloth.
இந்த ஹீட்டை வந்து
When the same
எடுத்துக்கிடுங்களா?
thermometer is covered with a wet cloth, we call it as a wet bulb temperature.
அந்த condenser
So why we use this dry bulb and wet bulb in the
இங்க வந்து
psychrometry?
கூலிங் அப்படின்னு சொல்லும்போது என்ன
ஹீட்
ஆகும்னா
தானே சார் வெளில
இங்க
போகுது?
வேப்பர் வந்து லிக்விடா தான் கன்வெர்ட் ஆகும். ஓகே, டெம்பரேச்சர் வந்து கான்ஸ்டன்ட்.
கியூ போகுதுல
ஆமா,
சார்?
ஹீட் தான் வெளிய போகுது. ஆனா என்ன ஆகும்னா
So
இல்ல இல்ல இங்க பாருங்க.
if we have the airflow here,
ஆமா, இந்த இடத்துல இருக்கலாம். இங்க பாருங்க, இந்த இடத்துல இதான கண்டென்சர் process.
a normal
சார்
thermometer.
கண்டென்சர் இருக்கு.
இங்க கண்டென்சர்
So that it will be
process
showing
இங்க வந்து
its temperature here.
சூப்பர் ஹீட்டர்ல
So when we I'll be calling it as a wet bulb temperature, the same thermometer is covered with
இந்த இடத்துல
a wet cloth
டெம்பரேச்சர்
or big
கான்ஸ்டன்டா இருக்கு இல்லையா?
when it is passing through.
அப்ப
When
என்ன
the
ஆகும்னா
air is passing through.
இது வந்து நம்ம
So obviously your wet bulb
கூலிங் அப்படின்னு
temperature
சொல்ல
will be
மாட்டோம். இந்த
always
இடத்துல
lower.
கண்டென்சர்
For
வந்து
example, actual temperature is
cooling அப்படி
actual temperature only this
voice
thermometer is
break ஆகுது.
showing 30 degrees Celsius.
கூலிங்
Here the water is surrounded
வந்து
by the
liquid-ஆ
wet bulb
convert
here. So the wet bulb temperature will be relatively lower. Maybe it may be showing some around 22 degrees Celsius. So what is the use of this?
இந்த ப்ராசஸ் இருக்குலமா இங்க வந்து
For example,
வெப்பர்
the air
ரெஃப்ரிஜரண்ட்
is
இஸ் கன்வெர்ட்டட்
completely
இன்டு லிக்விட்
saturated with the
ரெஃப்ரிஜரண்ட். அப்படிதான் நம்ம
water. So when it goes, it will not take any water from this. So it will be simply going.
சிக்னல் கம்மியா இருக்குன்னு நினைக்கிறேன்.
In other extreme,
Clarity இருக்கா?
the air is so dry when it is passing here. Okay, so it can able to take maximum
sir,
amount of
clarity
water
இருக்கு.
here. So accordingly, the temperature will be varying. So with respect to that, by comparing this temperature, we can able to understand that whether the moisture content present in the air, whether it is low or high, very precisely we can able to get. So that is the use of measuring the
இங்க வந்து
temperature.
நம்ம
We call it as a dry bulb
ஆல்மோஸ்ட் தெர்மோடைனமிக்ல நீங்க வந்து டெம்பரேச்சர் கான்ஸ்டன்ட்டா இருக்கு. என்ன ஆகும்னா இது வந்து ஹாட்டா தான் இருக்கும் இந்த இடத்துல வரும்.
And then coming to this dew point
என்ன டெம்பரேச்சர் இருக்கோ அதே டெம்பரேச்சர்
already
நம்ம
we
ஹீட்
have
எடுக்கிறோம் அப்படின்னு சொல்றோம். அந்த ஹீட் வந்து என்ன ஆகும்னா அந்த வேப்பரை வந்து லிக்விடா கன்வெர்ட் பண்றதுக்கு தான் அந்த ஹீட்டை நம்ம
when the
எடுக்கிறோம்.
water vapor will start to
நம்ம எடுக்கிற ஹீட் என்ன ஆகும்னா வேப்பரை வந்து லிக்விடா கன்வெர்ட் பண்றதுக்கு தான் அந்த ஹீட்டை நம்ம எடுக்கிறோம்.
saturated state.
இப்போ ஃபார் எக்ஸாம்பிள் இப்போ நம்ம வாட்டரை ஹீட் பண்ற மாதிரி
That point we call it as a dew point temperature.
இப்போ ஃபார் எக்ஸாம்பிள் இன்னொரு எக்ஸாம்பிள் ஐஸ் இருக்கு இல்லையா?
In the case
ஐஸ் வந்து நீங்க வெளியில எடுத்து வைக்கிறீங்க. ஐஸ் வந்து வெளியில எடுத்து
and then
ஐஸ் வந்து
coming to
ஃபர்ஸ்ட்
that
என்ன ஆகும்?
sensible
அது
heat
மெல்ட்
of
ஆகி வாட்டரா கன்வெர்ட் ஆகும்.
sensible heat of already we have
phase
studied
change is taking
sensible
place.
and latent.
அப்ப அந்த இடத்துல நம்ம கூலிங் சொல்றோம் இல்லையா? ஆனா ஐஸ்னுடைய டெம்பரேச்சர் வந்து இனிஷியலா 0 டிகிரி
Sensibility is
செல்சியஸ்
if I am
இல்லையா?
heating the air,
வாட்டரா
the
கன்வெர்ட் ஆகிற வரைக்கும் 0
directly
தான்
increasing.
நம்ம கூலிங்னா சொல்றோம்.
Then I can call it as a sensible.
ஐஸ் வந்து இப்ப எடுத்து நம்ம வெளியில வைக்கிறோம், ஒரு தட்டுல வைக்கிறோம் அப்படின்னா
When
0
I'm
டிகிரி
heating
செல்சியஸ்
the
ஐஸ்
air,
இருக்குன்னு வச்சுக்கலாம்.
the air temperature will not increase.
அப்படின்னா அது ஐஸ்
Only
தான்
phase
இருக்கும்.
changes
அதை நான்
மட்டும்
கூல்
தான்
பண்றேன்
சார்.
அப்படின்னா வெளியில எடுத்து வச்சாலே கூல்
The air will absorb
Only
heat.
phase
ஃபேஸ்
changes.
சேஞ்ச் தான் வருது. ஃபேஸ் சேஞ்ச் அப்ப நம்ம ஐஸ் வந்து என்ன
It's phase change.
ஆமா ஃபேஸ்
During the time,
ஐஸ் வந்து 0 டிகிரி
air
செல்சியஸ்ல
temperature will
அப்படி
not
இருக்குன்னா
increase. That we call
அது
it
நம்ம
as a
கூல் தான்
latent.
பண்றோம். ஆனா என்ன ஆகும்னா மெஷர் பண்ணா அது 0 டிகிரி செல்சியஸ்ல தான் இருக்கும். ஆனா
we need
கூல்
to
ஆயிடும்.
understand the
அப்ப என்ன ஆகுதுன்னா
difference
ஃபேஸ்
between
சேஞ்ச். அப்ப அதே மாதிரி தான் இங்க
sensibility and
நடந்திருக்கு. அப்ப என்ன ஆகுதுன்னா
The sum of its
temperature வந்து இங்க
sensible heat and
constant.
latent heat is
அப்போ so what will do it அப்போ ஹை டெம்பரேச்சர் தான் இங்க உள்ள வருது.
these are all
இங்க வந்து என்ன ஆகுதுன்னா so we have this இந்த இடத்துல already we have it a temperature rise here. அப்ப temperature difference இருக்கனால so here
is all about
the heat will be given here. So இது வந்து cool ஆயிடும். Okay, so that it will absorb heat. So it is coming to the vapor form. Further dry saturated state கூட போய் superheated state கூட
refrigeration
போகும்.
and
இது வந்து further heat ஆகுது. இங்க வந்து cool ஆகுது. So in this way we have
the analysis part later
cooling
that we'll see.
effect.
So we have
For the
derivation.
refrigerant which is entering into the expansion wall. We achieve heating when we